folks. So, pardon all those technical difficulties. For some reason, the stream stopped at 3 hours and 43 minutes. And it's 1 a.m. I woke up inexplicably on my own, so, I just came down here to fix things. And now that I'm down here, I'm like, well, I guess I might as well just be up for a while. So, yeah. Okay. Eclipse should be starting soon. It's about 1 a.m. Uh, yeah, I'll be right back. Alright, I am back. So, I took off my retainer, which I had on thus far in all these live streams, because my teeth need to remain not crooked. So, yeah, have to wear that during the night. So this is my first time doing streams from my phone, so it's all very work in progress, you see. All very, testing basis, trying to make sure everything works. So I don't know why the first stream ended. I shall now be investigating that. Yeah, I'm gonna investigate. Okay, so part 2's up, that's good. Okay, so, alright. What happened to part 1? My guess is that the app crashed, because when I came downstairs, the YouTube app, when I came downstairs, the app was not open. Like, it looked like it had just crashed. So, yeah, sorry about that, that's my guess. But, thankfully, it seems like you guys didn't miss much. Maybe an hour of looking at empty sky. So, yeah. Oh, wow, look at that. So, even though it is very cloudy, I can see the full moon right now. Full moon up above us. Yeah, let me just do a few things. I wonder if anyone's getting up to see this. Okay. Okay. Yeah, I saw a ton of people watched the first stream, and now I feel kind of bad because I'm like, there wasn't really much in that first stream. So, really didn't need to watch it. But there's the moon up there. Look at that. So, in the coming hours, that moon shall experience a few interesting phenomena. Okay. Let's see here. Let's go to time and date. Time and date doc. This is the best website, basically. Okay. I'm not even going to put qualifiers on that. It just is the best website, that's all. Let's see. Okay. Okay. All right. Timeanddate.com. Let's see. I don't want to. Here. Oh man. I am tired. I did not realize how tired I would be. Okay. I want eclipses. So I'm running a few clicks slow, that's all. Okay. This is live. Oh, so the eclipse has already started. Oh, well, that shows my location. Oh, well. So, 1:02 a.m. is when it starts, and it's 1:07. So, this is the live thing. So, the moon has just entered the very edge of the Earth's penumbra. The very edge of the moon just entered the edge of the penumbra. Now, I guess what would be useful is to see what that means for everybody. So, I'll try to explain it. I'm trying to think of a good way to explain it. If I should get some paper or something. It's funny. I just basically woke up like strangely, you know what I mean? Like, um, oh man. I woke up, I had set my alarms and stuff for 3 a.m. because I'm like, okay, I'm just gonna wait until then for the real fireworks to start. But I was up and I'm like, oh, okay. So I'm up. Yeah. The funny thing is, too, that tomorrow, or well, I guess it's today now, I have a stat test and a economics test. But that is fine. That's fine. I'll, I'll survive. Um, this is a priority for me, so I need to do this. So I'm not sure what I want to do right now in terms of explaining things to people. It's interesting, since it's a full moon and the full moon is at the zenith, when I got up, I probably woke up because of how bright it was through my windows, because it is strangely bright out here, but this is essentially as bright as it can get during the night because of the light of the full moon. You can see maybe not, but I can see my own shadow below me. When it's not cloudy, it's even more interesting how bright the moon actually is. It's crazy. I can see everything as if it were like twilight, maybe like civil twilight, astronomical twilight, yet it's the middle of the night. It's the middle of the night. My neighbors are probably, I should speak lower. Um, don't want them to think there's a crazy person. Oh, and the little, what would you call them? Calls, chirps. I wouldn't quite call them chirps because they're very low pitched, but we have Sandhill Cranes in the back here around this little pond. And they are basically giant birds, maybe not giant, medium-sized, if small is like a pigeon and giant is like an ostrich, okay? They're like dog-sized birds. Yeah, they're interesting. You can hear the low-pitched calls. Then there's also crickets, some sort of bug making a constant sound. Yeah, so we can't really tell right now, especially with these clouds in the way, that the eclipse has started, because the very edge of the penumbra is not much darker than just space. And the way that it's best to think about this is imagine this from the moon's perspective. So imagine you are on the moon and we want to ask ourselves, what are people on the moon? Well, there are no people on the moon right now, but if there were, what would they be seeing right now? And what they would be seeing is if they were on the very edge of the moon, all the way, I actually can't make out features of the moon right now, so I don't know how it's oriented above me, but based on that image I showed you, the people on the very left side, okay, left side of the screen, basically, the people over there, what they would be seeing right now is the very edge of the Earth beginning to eclipse the sun. So, that's interesting to think about. Once we get to the peak of this eclipse, what that's going to mean is almost all of the moon sees the entire Earth covering the sun. But this is a partial lunar eclipse, technically, not a total lunar eclipse, because only 97% of the moon will have that experience. Well, 97% of the part facing us, because that's another thing. No one on the back side of the moon can see the Earth. So right now they can't see the sun either, right? Because that's the thing about a full moon, right? A full moon, there we go. For a sphere in space, like the Earth or the moon or any planet in the solar system, with only one light source, that being the sun, half of that sphere is always going to be lit, no matter what. So even though we see the moon in phases, always half of the moon is lit, because it's a sphere in space and the sun is shining on it, right? But what we see shifts. So the half of the moon that we see is this constant tidally locked half, but the half of the moon that's light changes over the course of the month. So what we're seeing when we see a full moon right now is we are seeing the entire light side of the moon, and the entire dark side is facing away from us. So the day side is facing us, the night side is facing away from us. In 2 weeks, it'll be the reverse. It'll be a new moon. So the entire night side will be facing us, and the entire day side will be facing away from us. So basically, all the people on the far side, it's night right now, so you can't have a solar eclipse during the night, right? And that is what the moon experiences when there's a lunar eclipse. When there's a lunar eclipse on Earth, the moon is experiencing a solar eclipse. So the naming convention is not great, to be honest. because from Earth's perspective right now, nothing is being eclipsed. It's just that we are witnessing the effect of a solar eclipse on the moon. So, yeah, a solar eclipse on Earth happens when the moon blocks the sun. But from our perspective, our position right now, what's being blocked? Nothing's being blocked in the sky for us, right? But what's happening is that the nature of the moon, what we see of the moon in the sky, is changing because we are witnessing the effects of a solar eclipse on the moon. So, in conclusion, I guess, a lunar eclipse, a so-called lunar eclipse, what this is just the effects of a solar eclipse on the moon. So, from the moon's perspective, they're seeing the Earth pass in front of the sun, and that is like a solar eclipse if you've ever experienced a solar eclipse on Earth, right? So that's what's going on. But yeah, I think I explained everything that I was starting there. Oh man, this is bright. So I don't know why the YouTube app crashed the first time. Very sad. But that's fine. Because I'm here now. Strange that I woke up. I almost never wake up in the middle of the night, you know what I mean? Unprompted. Here's another interesting thing that's kind of funny. They say that this is like the longest lunar eclipse in some way for a very long time. I forget entirely what they mean about that. There's a ton of articles floating around about that. And the thing you have to keep in mind with pop sci articles is that they like to, I've noticed, they like to just add sort of useless qualifiers to things to say like, oh, this is the only time this is happening for like 500 years, when really some very similar things are going to be happening much sooner, right? So I haven't fully investigated this claim, but there is some truthfulness in that the moon right now is at its periapsis in the Earth's orbit, which is an interesting thing to consider, because at the periapsis, the Earth's umbra is smaller, the penumbra is larger, and the moon is moving slower through space relative to Earth, of course, because speed only makes sense in relation to something else. You can't have speed with just one object. I don't know if that's sort of like, that's relativity, but it's not even, it's Newtonian relativity, inertial reference frames, you know, that sort of thing. There is no objective standard of movement. You can't say that I am absolutely moving. Wow, listen to those birds, man. It's crazy. Those birds are up, flying, running around all day. I don't see why they're awake at night, too. I wonder if this is an anomaly of a night, like if they're awake for the same reason I am, basically. Or if, like, maybe they're, like, sleep talking? I don't know if animals do that. They are strange. They're also kind of pests sometimes, unfortunately, because they are very aggressive about food. And when people feed them, which you're not supposed to do, and we don't do, but some people around us in the neighborhood decide to feed the cranes. And you're not really supposed to do that, because then they will start going up to like other people's houses and really begging for food. But it's not begging, it's more like harassing for food. Um, Someone had their screen pecked in, this screen that you see around us, which you need in Florida to keep out the bugs. And this doesn't even perfectly keep out the bugs. There's bugs all over here. But it keeps out, I mean, we are literally, right, we're on a pond that is a giant thing of stagnant water, basically. So you would think I would be getting swarmed by mosquitoes right now, but thankfully, because of this net, I'm not. I would not be able to handle that. Just a ton of mosquitoes. No good. No good. Yeah. Let's see. So, I'm trying to think of like things I want to go get. I might want to go inside and get something and come back out here. Let's check the progress of the eclipse. Actually, I've been sitting down for a while. Okay. Oh, we can't really see anything because of the clouds. So, yeah, this is a touch and go experience here. I'm trying to think. I'm like, should I get a paper to try and explain the stuff here that's going on? It is interesting. Eclipses, lunar eclipses are just a fascinating experience. Oh, so I guess, yeah, the moon's at its periapsis, right? And that means that it looks smaller in the sky than usual. But it's not really noticeable unless you were to. I've never really noticed much of an objective shift in the size of the moon. Like, I haven't, just throughout my life and observations, I haven't really been able to notice the moon's size change, angular size changes, mind you, in the sky, because it's not that much. So the moon's orbit is elliptical, but it's not that elliptical. I could look up the eccentricity. Moon orbit. Alright, so the orbit of the moon has an eccentricity of 0.0549, which means that the periapsis. Oh, wait, I've been saying. Oh, no, I mean apoapsis. I am so sorry. Thus far, I've been saying periapsis, which means closest, right? Oh gosh, I should know this. I'm just confused. I'm dazed and confused because it's 1 a.m. and I'm awake inexplicably. Periapsis, the point in an orbiting body at which it is nearest. Okay. I issue a correction. I meant apoapsis. Okay, the moon is at apoapsis. Okay. So, at periapsis, the moon is at a distance of 95% from the Earth. At the apoapsis, it's at 105%. So it's not that much of a shift. It's only noticeable in like comparison photos. But yeah, so the moon is at apoapsis, and so it means it's smaller in the sky. It's interesting just being up like this. I'm gonna plug my phone in. I'm not sure what I want to do right now. I'm just trying to think. I have all my homework done because I'm like, I need to get this done beforehand and stuff like that. It's weird to be awake when no one else is awake, let me tell you. Not much to do. Tomorrow's my last day of school before Thanksgiving break. Yeah. It's funny, with the, like, stat test and economics test, I'm like, I hope I'm not this tired when it comes time for them. But it's like, come on, astronomy. Astronomy is very, very important. Uh, Especially such an event of such magnitude. This is probably like, I don't know, in terms of, if you were to like rank values, you've got like solar eclipse and then lunar eclipse. Lunar eclipse is like second most important kind of thing. Oh, look, okay, the moon is very clear. Let's see, do I notice anything? I guess it would be on this side. Maybe it looks a little bit clipped in the top left. Top left would be like with this orientation. I don't know if you guys can tell. Okay. Let's see. I'm gonna set you guys up for a second here because I don't know, I wanna like, oh wow, that's a lot more noticeable. I think you can definitely tell, I can tell at least, that, I don't know. You see, now the difficulty is the question, am I seeing the effects of the eclipse or the effects of partial cloud cover over the moon right now? So, tough question to answer, to be honest. All right, let's see if I can get you guys set up here to just watch this for a while. I'll be back out in like a second. I don't know. It's just like I feel like I want to grab a few things. That's all. Grab a few things from inside. Okay. Let's see, can I plug in, please? I need to plug in. Yes. Okay. Plugged in. All right, I'll be back. I'll be back. Terminator. now that now that the moon is shining through the clouds mostly, it's interesting how bright it is, the full moon. I mean, look, I can see my shadow now very clearly. My shadow in the moonlight. Okay. I don't know if you can tell on video. It's not the best. This is an iPhone camera. However, it is an iPhone 13 camera. And I have been very impressed with the iPhone 13 camera. Wow. I think I can definitely tell that the Earth's penumbra is covering half of the moon. Again, it's touch and go with the cloud cover. However, it is noticeable. Wow, look at that. So, yeah, science behind these things is great, but it's something else to just take it in. Look at that. I haven't watched one of these in a long while. Lunar eclipses. Lunar eclipses always get sort of tossed aside, disregarded. So the moon is about halfway through the Earth's penumbral shadow. And again, what this means is that half of the moon is experiencing the effects of a partial lunar eclipse. It's very, very fascinating. Yeah. From the perspective of the moon, the Earth has a larger angular diameter than the moon does from our perspective here on Earth. They're the same distance apart, but the Earth is about 4 times larger than the moon. So, in the moon's sky, the Earth appears about 4 times larger too. And so that is interesting because here on Earth, at this time period, solar eclipses where the moon eclipses the sun roughly line up in terms of angular diameter. People call this like a great coincidence. They say the angular size of the moon almost perfectly corresponds with the angular size of the sun. But on the moon, that is not the case. On the moon, the angular size of the Earth is 4 times larger than the sun, approximately. So what that means is that they experience totality in a solar eclipse for a lot longer than we do here on Earth at any given location, because the Earth's umbral shadow is actually larger than the moon at the moon's distance. So the Earth's umbral shadow is larger in diameter than the moon is in diameter. Whereas here on Earth, we know that the moon's umbral shadow is tiny. If you've ever tried to go see a total eclipse, you know that it's like a 10-20 mile band where it's even ever visible. So the moon's penumbral shadow, or umbral shadow, here on Earth is only a few miles wide. But the Earth's umbral shadow on the moon is huge, right? So yeah, it's just an interesting effect of light, basically. Since the sun is not a point source, since it has angular size, there is necessarily going to be an umbra and a penumbra, and of every single shadow you see, every single shadow. We always talk about umbras and penumbras when it comes to astronomical bodies. But really, during the day, your own shadow has an umbra and a penumbra when it hits the ground or a wall behind you. And these shadows are basically two giant cones that extend outward from you into space, with different properties. So the penumbra, since the sun has angular size and isn't just a point source, the penumbra is where that angular light source is partially blocked. And so that means to varying degrees. The penumbra at the very edge seems like almost nothing has happened, but at the other edge, right next to the umbra, it seems like quite a bit has happened. It's almost entirely dark because this is going from like 1% to 99% of the sun's angular size covered. So the umbra then is the zone where the sun is fully covered. And that has some interesting implications. So every single night, people on Earth are inside the Earth's umbral shadow. Now, it might take a moment, but think about it. The sun, if we were to draw a straight line from here to the sun, that straight line would go underground. So the sun is beneath the Earth because it's nighttime. And that means that this giant Earth that we look down and see, and it encompasses half of our field of view, this giant Earth is blocking out the sun. And it's blocking out the sun entirely. So that means we're in the umbral shadow. Simple as. Yeah, and it's really interesting. And if you've ever held your hand up in the sunlight to see your own shadow, right? You may notice that as your hand is closer to the ground, your shadow seems sharper. And when you lift your hand up, the shadow seems fuzzier and blurrier. And that's because as you lift your hand up, the umbra is getting smaller and the penumbra is getting larger. Because from the perspective of the ground, your hand is getting smaller in angular size, which means that there are less conditions where the angular size of the sun is entirely covered, and there are more conditions where it's partially covered. Eventually, when you go out far enough, the umbra shrinks to zero. And there's a term for the other side of the umbra, where it's like after the umbra. I forget what it's called though. it has to do with annular eclipses. But yeah, this is just interesting. I think I'm not gonna talk as much now because, like, I don't want to hurt my voice, and I already know I'm gonna be tired tomorrow, so I'm just like, I'm just gonna sit here for a bit, you know, take it in. I'll talk to Chad if there's any chat, but yeah. I'll be right back. Look at that. It's a good thing that I decided to get up because the weather reports were saying all cloud cover, cloud cover, but then you get giant clear patches like this. Then you get giant clear patches like this. I apologize to the stream people right now that the moon is behind a giant steel girder, essentially. But if you're anywhere in the US, you should be able to see this yourself. Oh, hello from Toronto, Canada. Alfredoistic. Hello. How's it going? Yeah, I think if you're in Canada, you should be able to see this too. Yeah, pretty much anyone in the US, anyone in Canada, even parts of like Europe and Asia should be able to see this. Part of it, at least. So there's another very interesting thing about being in the Earth's shadow that is quite unique to the Earth. And that is the fact that the Earth is a planet with an atmosphere, a significant atmosphere. The moon has no atmosphere. So when we watch a solar eclipse, the moon just is a giant rock that blocks out sunlight. But the Earth is a rock surrounded by an envelope of gases. So when you're on the moon and you're in the umbral shadow of Earth, what actually happens is you get bathed in red light because the solid Earth has blocked out all direct sunlight. However, there's still light that has streamed through the Earth's atmosphere, bounced around a bit in the atmosphere, probably bounced just once off of one molecule and then right back into space. And in that process, the brighter wavelengths of light get filtered out, brighter, higher frequencies, so blue, violet, green, get filtered out, and the lower frequency, lower energy light gets through, like red light. So when you're on the moon in the umbral shadow, you will actually be bathed in red light, and that is a ring. You would see a ring in the sky where the center of the ring is black. Actually, the center of the ring might have some city lights on it, right? Because it's the Earth. And around that blackness is going to be a ring of red light, and it would be a very eerie environment, I imagine. I tried to write a lunar eclipse into my first book, actually, because my first book takes place on the moon. And I was like, wouldn't it be cool to have a scene where I describe a lunar eclipse from the moon's perspective? However, the timing just didn't work out. So the time when I wanted the book to be set in didn't really coincide with any lunar eclipses, so I was like, okay, that's okay. I can write a short story or something later that describes this, seeing this from the moon. And trust me, if I write a short story about this, I'll be a lot more eloquent and organized in my presentation than I am right now. You know, when I have a piece of writing and I polish it for months, I am a lot better than when I'm up at 1 a.m. tired and improving. So, yeah. So the moon is about 2/3 into the penumbral shadow. We're almost going to arrive at the stage where the moon enters the Earth's umbral shadow, and that is going to be a significant shift. that we're going to notice a lot better on camera. You're going to notice that a lot better. I can definitely make out the shading of the umbra on the left. It's definitely noticeable for me, probably for you guys too, if you're watching the eclipse at home. Seems like a few other families around here have decided to stay up for the eclipse as well. So that's cool. I like to see people getting involved in astronomy. The moon is almost entirely in the Earth's penumbral shadow at this point. The night is quite beautiful, I must say. When you have a full moon, it's pretty cool. It's like an eerie, but not quite bad space where the light is very dim, but you can still see quite well because of the full moon. Very, very interesting. These bird calls of these giant, dog-sized birds, these sandhill cranes, I imagine they're similar to what the dinosaurs sounded like. Which is interesting. Gives this quite an eerie environment. I imagine it will be very eerie when we are bathed in the red light of a blood moon, all the sunsets and sunrises in the world, hitting the moon, reflecting back at us, creating a dark red environment with dog-sized birds calling like dinosaurs all around us. Oh, look at this. The Griffith Observatory is doing a live stream. They're out in California. Yeah, seems like they're pretty much doing what I'm doing. It's just a live feed of their view of the moon from the observatory, a lot clearer than mine, but they don't have my brilliant commentary, do they? So, of course, that is sarcasm. Yeah, this is a good stream. Good stream. I'll link this actually. This is good. I hope they leave the VOD up of their live stream, the Griffith Observatory, because this is a very good Griffith. Yeah, with my 2 tests at school, and like, when school this morning in a few hours or whatever, I'm like, okay, I need to make sure that I really know about the Phillips curve and expected values. All right. I'm like, they need to be second nature to me. I need to be able to do them in my sleep, because I'll practically be asleep. I don't think it'll be that bad. Usually, like, I'm not that tired even after a night of poor sleep. It's usually the next day that you really feel the effects. So, but I don't know. These are sort of exceptional circumstances. This isn't just a bad night of sleep accidentally, you know what I mean? This is like intentionally up half the night. So, we shall see. Tired. The umbral eclipse should be starting soon. 10 minutes, it seems. Thus far, I have been very pleased with YouTube's phone to live stream system. Very easy. Almost like doing like a Facebook Live or an Instagram Live. So simple. Which is very good. That makes me happy. I think I'm gonna do something like this again, maybe soon. I have my eyes set on the Geminids meteor shower. I think that's the morning of December 13th or 14th, something like that. It's another school day, school night, so. But the Geminids is like a very active meteor shower, and I think I'd love to watch that. So yeah, expect a stream sometime in December. Yeah, so I would say it's not the umbral yet, but what you can see is that one side, the darker side of the moon thus far is looks like it's chipped almost. And so those areas of the moon are approaching totality. And so falling back on my experiences, my 2017 total solar eclipse that I saw in Clemson, South Carolina, it's just making me think of the perspective of the moon. They're seeing a very similar thing, except the Earth is larger in angular diameter and should have diffuse light moving around it. So, quite interesting. It would be quite interesting. It's cool that NASA, you know, they have their Artemis program, and so they want to establish a permanent moon base by 2025-ish, late 2020s. And so if that occurs, that's very interesting, because that means we'll have people that experience a lunar eclipse from the perspective of the moon for the first time, which I imagine would just be brilliant, like just amazing, because solar eclipses on Earth are pretty cool. Imagine being on the moon and seeing one. No one has seen that yet. That's a thing that people have yet to experience. People have yet to experience a solar eclipse on the moon. And remember, a solar eclipse on the moon is just what we're seeing now. It's a lunar eclipse. What we call a lunar eclipse is a solar eclipse on the moon. It's all very confusing, and that's because I don't think the naming convention is that good. Because, like, a solar eclipse means that the moon is blocking out the sun. So what you would think is that a lunar eclipse would mean that something is blocking out the moon. But that's not really happening. We can see the moon through the whole lunar eclipse process. It's just that it's in the Earth's shadow. So, I don't know what a better naming convention would be. I just know that it makes it hard to explain things, especially at 2 a.m. So. Just a few minutes until the umbral lunar eclipse begins. So, yeah. So this is interesting. For a few minutes, and right now this is one of those minutes, the moon is entirely in the Earth's penumbra. The moon is entirely in the Earth's penumbra. So none of it's in the umbra, and none of it is out in space. So everywhere on the moon right now is experiencing a partial solar eclipse to varying degrees. Now, I'm just going to keep referring to this as the left side for the entire stream, because if you look at the moon upright, it is the left side, but from our perspective, it's like upper right now, because whatever. There is no up or down in space, which means there is no left or right in space. So I'm just going to call it the left half going forward, just because it's like so much easier than explaining this every time. So left side of the moon is experiencing a partial solar eclipse that's almost total. The right side of the moon is experiencing a partial solar eclipse that's almost nothing at all. So, yeah. T-minus 2 minutes on the moon entering the Earth's umbra, and the partial lunar eclipse, as it's phrased by people on Earth, shall begin. So 2 minutes, guys. Pretty cool. Listen to those things. velociraptors, I swear. That is frightening, let me tell you. Thankfully, the Sandhill Cranes are herbivores. Oh man. T-minus 20 seconds till umbral eclipse. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So the umbral eclipse should be starting now, the partial lunar eclipse. Hey Mom, what's up? Oh, it's fine.
I came down to go to the bathroom because I was throwing the paper upstairs, and I was like, is someone sitting there? And I'm like, oh, it's because the moon thing. It's so cool.
So, not much to see right now, but can you see that the upper part of the moon is slightly shaded?
Yeah, and I definitely see the like big circle around it.
The big circle. Oh, that's just like the clouds. That's
okay.
from the clouds. The main. Yeah, the main. That's just yeah. That's an effect. That's like haze. You know.
Yeah.
But
You're so cute. I looked down and I was like, is somebody sitting here? And I'm like, oh, of course.
But the main thing is that the top part of the moon is like chipped. You can see.
Oh yeah, I do see that.
And that is the part that's in the Earth's umbra, which is the completely dark shadow.
Very cool.
That's like that part of the moon that's chipped is experiencing the totality of the solar eclipse from the perspective of the moon. So if you remember what we saw during totality, that's what that part of the moon sees, is the entire Earth blocking out the sun.
Very cool.
Now, as time goes by and over the course of the next like hour, the moon is that chipped part is going to increase in size until the whole moon is almost completely darkened. But then it becomes red because of refracted sunlight.
What they call the beaver moon, right?
That's the part that they call like the blood moon. The beaver moon.
The blood moon.
The beaver moon is basically, that's part of the naming system where each month's full moon gets a name.
Okay.
So January is like the wolf moon, February is the snow moon, etc., etc.
Is it as clear as you hoped it would be? Because I know you said I'm not sure with the Florida sky.
I would have liked it to be just 100% clear. However, the weather reports were saying like 100% cloud cover, which would be like, I mean, think about how it was today. Overcast all day.
That's true.
Completely 100% overcast.
So you're happy it's better than,
I'm very happy that it's better than the weather reports predicted. So.
Excellent. Yeah. You're so good. It's so funny. I came there just to use the bathroom, and I got a picture that I look outside and I'm like, looks like someone's sitting there. And at first I was thinking like dangerous. That it wasn't you, that it's like someone was just sitting there with it. And I'm like, oh, duh, it's the moon thing. So were you able to wake up, or did it feel tired to wake up?
I mean, I am tired, but like, I woke up on my own. I didn't even need the alarm.
That's cool.
Because I was only going to wake myself up at 3 a.m. So that the eclipse would be mostly like partially underway at that point.
Yeah.
Because there wasn't much to see up until now.
Right.
But I'm glad I just woke up on my own anyway to see the whole thing. So.
I'm psyched for you. Well, I'm gonna go back to bed, but I love you.
Love you too.
I'm glad it's working.
Yeah. That was my mother, so. Look at that chipped face of the moon. That is quite cool to see. You don't really see that. It's all unnatural. I mean, it's natural, of course, but like, you must imagine these rare events if you were in the ancient times and you didn't know why this was happening, and it seemed random and you couldn't predict it, and you had no real explanation. Imagine how frightening it must be. It would be an event that you would put a lot of mythological significance on, you know? You would be like, what is going on? This must be a supernatural night of, you know, demons and bad spirits and whatnot. So it's very nice that we are in this enlightened age, right? Although it sometimes doesn't feel like it, you know, but the average person is actually a lot smarter than they ever were in humanity's history. That's a great achievement, we must remember. And so in that context, it's like, this is an eerie setting, yet there's like magnificence in it. Oh, look at this. The timeanddate.com people are doing their own live stream. Let's see what they have to say.
Looks like the moon is eating a black hole into the sun. But during a lunar eclipse, Earth has an atmosphere, so the light from the sun hits Earth's atmosphere. We can look at a diagram there, and the blue light particles coming from the sun gets hit.
I don't want to steal their stream, so I'm not going to keep playing that on my stream. You know, we frown upon that here at the Gravity Max live stream. Gravity Max Astronomy nights, really. So I'll put their link, though. I'll definitely add that description. I imagine the commentary is basically science explained a lot better than me because they have prepared slides and stuff, and I just have prepared waffling as. Oh my gosh, I can't believe I said that. That's a phrase I learned from my brother. Waffling. Apparently, it's like British slang for just rambling and going on and on about not much. So, I'm waffling. Yeah. Yeah, the Umbra is a lot more significant than the Penumbra, you know? There's a lot more going on. But it's also, again, it's fuzzy because the area around the Umbra is technically Penumbra, but it's so close to a total eclipse that it does look very dark too, so it's a fuzzy boundary. Huh. And another interesting thing is that it's noticeably darker out here. Now, I wonder how much that is just due to the cloud cover at this time, and how much that is due to the fact that the reflected light from the moon is diminishing. There'll come a point when near the maximum of this eclipse, where the ambient light around me will just be the scattered sunsets and sunrises of the world fired back at me, which is just fascinating to think about, to be engulfed in the light of sunrises and sunsets. Another interesting thing is that, like, this umbral and penumbral shadow that we're seeing, it's always there in the night. It's just you don't really notice it because usually there are no objects in the moon's orbit other than the moon, and the moon usually just misses that area where there's an umbra and a penumbra. And so when you look up at night, you'll often just glance over it like it's nothing, like there's nothing there, because there really is nothing there. It's just a space. It's just a piece of space where there happens to be not much light. And it's just always there. But the moon just never intersects it. And stars that are like hundreds of light years away aren't in the right spot because you need to be in the moon's orbit for the penumbra and umbra to be there, right where they are right now. So I don't know if that made sense. That didn't. I might not have been specific enough, basically. But I'm going to readjust this quote-unquote tripod to get more of the moon in shots. Let's see. Let's see. Okay. That's good. Oh yeah, you can definitely tell that something is up, can't you, on the stream? Yeah, cool. Again, there are much higher quality streams in terms of what they're seeing, but it's just nice to be here with anyone else daring enough to be up at this insane hour and leave a comment. So, yeah, I'll talk to any commenters if there are any, when there are any, because there already has been, and I talked to him just briefly. One thing I'm glad about is that it's not that cold out. It's nighttime, and it's November, but it's not that cold out because I live in Florida. Now for, born and raised Floridians, I imagine it's cold out. But Floridians don't know cold. When you've lived in Connecticut, you know that nothing in Florida can really be described as cold. Cool, maybe, but not cold. It's not cold here. Although something interesting is that since I've gotten used to how hot it is during the summers in Florida, it has felt kind of cold over the past, week. And that's just interesting because if I were still living in Connecticut, I would not describe this as cold. I guess your body just slowly adjusts to wherever you're at, wherever you are, so wherever you live. Your body's mechanisms for heat transfer slowly alter. So in a place where it's just during the summer consistently 90 degrees Fahrenheit and really humid, your body just has to learn a better way to get rid of waste heat, which is very difficult in air approaching body temperature because it's there's not much room to cool off. So the cloud cover right now is particularly obscuring. It's a particular nuisance right now, which is again, still better than expected. Expected was we weren't going to see this at all, so I'm glad that we see this at all. While we have this cloud intermission, I would like to again, courtesy of timeanddate.com, look at that. That's what we're seeing right now. So the dark part, umbra, semi-dark part, penumbra. Look at that.
Look at how that chip turns into about half the moon being like eaten away. Beautiful, beautiful sights. About a third of the moon is in the Earth's umbra. So we're gonna arrive at maximum eclipse in an hour 15 minutes, 4 a.m. pretty much. And I think at that point, 4 a.m., I'm gonna go back to bed, get 2 more hours of sleep, and then go to school tomorrow. Today. Today is tomorrow. Yeah, I'll leave the stream running though, of course. I might actually start a new stream, a part 3, at that point at 4 a.m. because, again, the part 1 stream, like, crashed or whatever, and so if that's something dependent on the length of the stream, if YouTube just, on the app, just can't handle streams that go longer than, like, 3.5 hours, then I don't want to have the tail end of the eclipse get cut off. But again, the thing is with this partial, this lunar eclipse, is that the second half of the eclipse after maximum looks pretty much the same as the first half, except in reverse. So it's like, I don't need to stick around for that. I should probably get some sleep so that I'm not horrible at school tomorrow. But yeah. I will leave the stream running though. And that's not for another hour 15, so yeah. Plenty of time to enjoy the eclipse. I have like pollen allergies or something. Take an allergy pill every morning, but it is, 20 hours since I've last taken an allergy pill, so I am very sneezy right now.
Let's see what it looks like when we zoom in. All right. Zoom time. Okay. Look at that. You can totally see that. I'll leave it moderately zoomed in. Let's see. Okay, you can't see. Okay. Let's see, maybe I can. All right, cool. I'll leave it like that for a while.
0.44, magnitude 0.44. So magnitude is a measure of lunar eclipse strength that I just realized. It goes from 0 to 1. And basically, it's how much of the moon's diameter is covered by the Earth's penumbra. And so at this point, 0.44 of the moon's diameter. So 44%. Now that doesn't 100% mean, that doesn't match area, like angular area, if that's a thing, angular area, angular size, because the moon is a circle in angular area. The angular space is two-dimensional, right? It's a two-dimensional surface of this celestial sphere. So the moon is a circle, and the Earth's penumbra is also a circle. So just because the Earth's penumbra is covering 0.45 now of the moon's diameter, that does not mean that it's covering 0.45 of the angular area. So it's slightly different. The maximum eclipse will have a magnitude of 0.974, so 97%, but the obscuration, which is the moon's angular area covered by the Earth's umbra, will be 99.1%, so slightly higher. And of course, you could calculate it. It's just a fairly simple, 8th grade geometry problem, 7th grade geometry problem, but, it's like, it's still hard. It's not like I can just square it, you know what I mean? That's something that I can do almost in my head, right? But I'd have to bust out the paper and pencil and all that stuff. Almost like an AMC problem, the American Math Competition. If you're at all familiar with the AMC, American Math Competition, on stream, then you'll know what I'm talking about. It's like, find X, and then they give you all these parameters, and you have to find X, and it's like, yeah. Wow. Look at this. 0.47 magnitude. You can really see it, and it's really cool. And I'm starting to see hints of red, but I may just be imagining that, because, of course, a lot of things in astronomy, there's what you expect to see, and then there's what you actually see. And what you actually see is often vague because, it's dark, our eyes aren't exactly evolved for these conditions. So sometimes what you think you see is partially imagined. But usually it's not entirely imagined. Usually what's going on is that you see something slight, and you also have your preconceived notion, and your preconceived notion is being confirmed by the thing that you're seeing slightly, and so your mind tends to exaggerate. At least that's the way I feel. I haven't done any studies on this, of course. I don't know if it's too vague, it's too qualitative to make this a study. What I'm rambling or waffling about, so yeah. But still, very cool nonetheless. Like at this point, the moon almost looks like it does when it's like a fairly thick crescent, but you can definitely tell, like, something's off, something's not quite right up there. And it's definitely getting darker out here because we have less moonshine, moonlight coming back at us. also have to do a presentation in my philosophy class tomorrow. Today is tomorrow, of course. I've noticed that there are two kinds of days before a break, of like the day right before the break at school. There is the everything's done and I don't want to start something new yet, so we're just gonna have a chill day. And then there's the we've packed everything down to the last minute and we're rushing to get the final things done before break and you forget everything day. So I feel like, unfortunately, this school day is going to be one of the latter. So I can't just, sit and nod off as like teachers play YouTube videos of whatnot. Unfortunately. It's now 3 a.m., everybody. 3 o'clock in the morning. It reminds me of those clickbait videos. Don't call so-and-so at 3 a.m. challenge, right? Don't watch a lunar eclipse at 3 a.m. challenge. Oh, you can definitely see the red. Maybe not on stream, but for me. Something interesting to think about is when we experience a solar eclipse here on Earth, what would people on the moon see? And what they would see is a small shadow pass over the Earth. That's about it. Not as grand as what we see when we experience what is a solar eclipse on the moon. Because moon, no atmosphere, very small, so very small shadow, doesn't cover the entire Earth, blah blah blah. But the Earth, atmosphere, large shadow, it's quite a dramatic event. Let me readjust this camera for the celestial sphere moves across, it rotates, and so the moon rotates with it. All right, I've overcorrected slightly, but I'm going to leave it that way because the moon's going to drift right back into view very soon. I'm going to walk around up here for a bit.
As more of the moon falls into this umbral shadow, more and more stars are actually becoming visible because the night sky is getting darker without the full moon. That is why the best time to view basically every object in the sky other than the moon is when there's a new moon. Because just like the sun does, except to a lesser degree, the full moon overshines all the stars around it. And so it's hard to really see much, especially dim objects. Hard to see dim objects on a full moon night. So, yeah. But this eclipse is going to temporarily reverse that, which is interesting. Alright, I will be right back. I'm gonna go to the bathroom. I'm back. Eclipse magnitude 0.62.
you're looking at it from the other side.
Someone in the comments of Time and Date's stream called this a Disney moon, and that is comical because often in TV movies, whatnot, you get these crescent moons that are exaggeratedly sharp, and that doesn't really happen in the normal phases of the moon because that's just not how the geometry works out. But this eclipse, seems to defy the typical lunar geometry. And now about 2/3 of the moon is in the umbra. Very cool. Yeah, you can totally see the reddening of the dark side of the moon right now. I mean, it's not the dark side. Umbral, whatever. You know what I mean. Alright, looks like it's time for a readjustment here. Yeah, the problem is this, I don't know, some metal, girder, basically, that makes up this cage, to screen out the mosquitoes. So, yeah, it'll pass soon.
see if I can move this. There we go. It's difficult. Okay. Look at that. Love to see it. Ah.
I wonder what the Sandhill Cranes, I wonder what they think of all this. I wonder if I brought my dog out here, what she'd think of all this. I wonder if they even notice. I mean, some animals really value the moon, like, in terms of all their evolutionary stuff, their instinctual stuff, but, the ones that don't probably won't think twice about this. So. We're at a magnitude of 0.75, 0.74, almost 0.75. 3/4 about of the moon is in the Earth's umbra, experiencing a total solar eclipse. Very, very cool. Very cool. Look at that beautiful clear image. All the clouds are out of the way. interesting. I wonder if the people on the flight are taking a look out their windows. Oh wow, I think I just saw a meteor, so it didn't pick up on the stream though. It was off to the left of the moon. That's cool. Lunar eclipse and meteor at the same time. That could be a holdover of the Leonids meteor shower. The Leonids meteor shower peaked 2 days ago, but meteor shower peaks aren't really an exact science. It's not like once and then never. So yeah, it's just a period of heightened activity basically. magnitude 0.81. About 4/5 of the moon is completely covered by the umbra. Looks like a cloud's moving through, unfortunately. I don't know if anyone's watching, but feel free to chat, because I will respond. Let me fix this for you guys. Readjust. Okay. Yeah, I am fading, definitely. I'm tired. Once this gets to maximum eclipse, I'm gonna go to bed. But yeah, okay. I think that's a good spot. I'll check on it. Make sure. Yeah, let's go. Oh. Yeah, okay. Yeah, it's getting darker. I mean, I'm repeating myself, but I am impressed, amazed by how dark it's getting. I haven't watched a lunar eclipse in a while, to be honest, so I'm glad I'm doing this. Yeah, it's becoming a moonless night, essentially. Very interesting to me. Uh-oh. Yeah, major cloud cover here. It's pretty much gone. But I can see clear patches of the sky nearby, so hopefully this cloud will pass promptly. I made an Instagram/Twitter/Facebook post earlier saying that clouds are an astronomer's worst enemy, and I still hold that to be true. thankfully this isn't a solar eclipse, because solar eclipses are very touch and go events, because they're over really fast. I think the totality I watched in Clemson was like 2.5 minutes maybe. The partial phases of the solar eclipse lasted for a couple hours, just like this lunar eclipse, but the lunar eclipse, this is very long. I mean, all told, from the tip getting to the penumbra until the tip leaving the penumbra, I think is 6 hours or something, because this is an especially long lunar eclipse too. So yeah, interesting things going on. It looks like the clouds are letting up a bit. I can definitely tell that the moon is a little bit red tinted on the darker parts. looks like a lot of overcast is drifting. Unfortunately, we'll see what we can in these next, 20, 30 minutes, and I'll go to bed. And I'll make a part 3 stream for you guys, leave it running, to catch the tail end of this eclipse. Eclipse magnitude 0.9, so about 9/10 of the moon is covered by the umbra, and the other 10% is covered by clouds. So, yeah. Bad luck with the clouds here. Yeah. Well, you can't expect too much, I guess, I mean, the weather reports were saying it would be like this, like it is right now, all night. So I'm just glad that I was able to see like 2 hours so far of the penumbral and then partial lunar eclipse. Got pretty close to the maximum before this cloud cover, and we still have like 20-ish minutes until maximum. So we'll see what we can see. We'll see what happens. Alright, I'm gonna zoom out because I'm not sure if I've lost camera sights or if I've just, like, lost it to the clouds. So, I'm gonna put this back down. It's not zoomed in anymore. Let's see what can be seen. Looks like you can see it slightly. Oh yeah. Yeah, look at that. Blood red moon. Alright, 10 minutes until maximum. But the maximum isn't like a sharp instantaneous moment. You see, we're already at magnitude 0.96 and the maximum is going to be magnitude 0.974. It's kind of like a sine wave or the top of a parabola, something like that, if you're trying to think about the magnitudes over time. But yeah, you know, I guess this is sort of showing the difference between a partial lunar eclipse and a total lunar eclipse. Even this partial lunar eclipse that's so close, where only 0.9% of the moon is visible in penumbral shadow instead of umbral shadow, still that penumbral part seems to be outshining the blood red of the rest of the moon. And so the result of that is that you don't get as much of a blood red effect as you do during a total lunar eclipse where there's a rich red blood effect. Yeah. It's noticeable, the blood red effect, but it's just not super prominent and probably won't show up great on camera. On iPhone 13 camera, at least. I think it's really great, the iPhone 13 camera, but it's still a phone camera. There's only so much that it can do. Yeah, on the time and date stream, you can really see how red it is. Let's see what they're talking about.
Yeah. A red moon, we can see that Gary has adjusted his camera, and we're looking at an awesome blood moon here. This is why they call it the blood moon, because it goes blood red.
What a sight. What a sight. Yeah, it's really interesting. It's like this tiny little tic-tac of light on the left side of the moon. And then it fades into a gray in the middle of the left side, and then the right side is dark and red. Cool to see. It's like iron red. I imagine that's what like Mars would look like if you were able to view it closer up. Because in the night sky it's just a point source essentially, but it's noticeably red, orangey. look at that. I didn't notice this until now, but up and to the right of the moon is the Pleiades star cluster. I'm not sure it shows up on stream, but interesting. But yeah, we're just about approaching maximum eclipse right here. Magnitude 0.974. It's just great to take it all in. I hope that you're all watching at home live, because it really doesn't compare on video. Yeah, I'm just thinking about, like, my book, first book, A Truly Dead Rock. If this eclipse were taking place in 2102 in the book, you know, the people at the North Pole in the city of New Armstrong right now, they'd be seeing quite a sight. They'd be seeing a total eclipse just on the horizon. They'd be seeing the Earth and all of the lights of the night side of the Earth over North America and South America, and they'd be seeing a red glow around that where the sun is behind. People in the colony of Plato or Kepler, they would be seeing a similar thing, except it would probably be better because it would be closer to the zenith for them. Oh, there goes another meteor, another Leonid maybe. Wow. And then people at the South Pole, Chang'e Bing or Tycho, they'd probably be seeing it too, to varying degrees and closer to the horizon. So this would be an entire moon-wide experience for them, except for that small part off to the left, bottom left, that's not seen it. But they're seeing something very close.
All right. So, very cool, right? I think what I'm gonna do now is I'm going to stop this stream and start a third one, and I'm gonna go to sleep because I'm tired. But yeah, that was really cool. Very, very cool. I'm so glad that I got to see that. I haven't made the time to see a lunar eclipse in quite a while, so I'm glad about seeing this one. Um, so yeah, pretty cool. I also think that this, streaming setup I'm pretty pleased with, so I would like to do it again. Hopefully with the Geminids is what I'll do. So, yeah. Thank you all for watching, and watch part 3 if you want to watch the tail end of the eclipse. All right, see you guys in just a second. Here, wait. Just